Our next speaker is Dan Guido. And Dan was born in Queens. He's a local guy. Where are you? You're scaring me. You're walking behind me here. He is the local guy. And I asked him, said, so who's going to the World Cup? And he just said, very straight face.
My dad's an American football coach, so I don't watch soccer. Sorry.
So it's like, forget it, right? And then, one of the colleagues there on the front row asked him, said, so who's going to win the cybercurrency World Cup? And he said,
I am.
So there you go. All right, so Dan,
thanks.
Stage is yours. Thank you.
Yeah, Lorenz, thank you for the great introduction. We work on technology that's quite like Securify, and I'll go into a little bit more detail about some of the challenges and some of the possible solutions to issues exposed by smart contract technology. And I will wait for my slides to get up to tell you more. So I'm the CEO and co-founder of Trail of Bits. We're a local cybersecurity research and development firm here in New York City. We have about 36 folks that work for us. They're spread out all over the globe, and we focus exclusively on low-level technology. But the specific slice of the company I'll talk about today is our blockchain team. So we work with a lot of the major players in the space. You might be aware of some of these from the hacks that they have suffered, and those people tend to come to us when they need professional help to deal with them. To just dig into a little bit more detail about what we're actually talking about, Lorenz gave a great introduction, but I'd like to discuss it at a lower level. So we're talking about Ethereum typically. Everybody knows Bitcoin. Bitcoin is like the first big blockchain out there, but Ethereum is this alternative blockchain that includes the ability to write smart contracts, which are these little autonomous finance bots that can receive transactions and manipulate global state. It's the second largest cryptocurrency by valuation, and it's full of scams. So this picture is actually the creator of the Ethereum blockchain, Vitalik Buterin, and this is the blockchain version of holding up a newspaper with the current date on it to prove you're not dead. And that's because there was a death hoax circulating to manipulate the price of Bitcoin by claiming he had died. So at kind of like a little bit of a medium tier here, what you're really looking at is a shared global computer where there are people that have the ability to send inputs to contracts, autonomous finance bots that have code that gets run when they send those inputs that manipulate state or, let's say, balances. The fun thing about the Ethereum blockchain and most other blockchains that implement smart contracts is that anybody can see every transaction that occurs on it. And you can send any input you want to any contract on the network. So this has lots of really fun secondary effects. The way that you program these finance bots is you use a language called Solidity, primarily. There's many different languages, but Solidity is the most popular, and it's the most popular because it looks like JavaScript. The Ethereum folks understood very well that nothing matters unless you get developers, so they focused the development methodology for their smart contracts around something people already knew, which was JavaScript and Node.js. So this compiles to a custom binary format called EVM. It's a bytecode format. And it is the source of nearly all of Ethereum's issues. The thing with Solidity is it was created only a few years ago, whereas you've got languages like C and C++ that are 40 years old, and we're still discovering new issues with the language itself. So this language is not really so much created as it is evolving. And that's kind of part of the problem, because this language has reintroduced so many vulnerabilities that were removed from other safer ones that it creates many opportunities to shoot yourself in the foot as a developer. So for instance, for any of the programmers in the audience, null dereferences are exploitable on this platform, something that you would never have to consider in any other modern language you use today. But in Solidity, it allows someone to steal all of your money. So there are real consequences to this. Lorenz helpfully showed a few others. These are all people that lost tens of millions of dollars because of specifically smart contract flaws. So the blockchain technology is very unforgiving. When you have a security problem in one, you immediately lose tens of millions of dollars. It's not like hacking a web application or a company or a reversible transaction. The point of the blockchain is that it's immutable. You can't roll back state. So when you lose, it's gone. So I want to walk through what it looks like from a hacker's perspective to steal all this money. So step one is you go on a website like this and sort all the contracts by value, and you find a good, expensive one. And then you choose literally any contract. Step three is you read the contract source code and look at the warnings, and those are all the bugs. And step 4 is you write the exploit. That's it. This is the process that hackers go through to exploit smart contracts. It's trivial, and it works incredibly well. So this exploit right here just sends one transaction. So I mentioned before that null dereferences are exploitable. So this first transaction calls into a smart contract, and what it does is it sends a little bit too much data, and it clobbers what's called the owner of the contract and sets it to 0. And when the owner of the contract is 0, that means that you are the owner. So the second transaction there calls the contract again, but uses it to cash out all the value back to you. So a hack in smart contract land means that you send a contract more value than less value than it sends you. That's it. So that's how you hack smart contracts. All of you guys can be millionaires now. So what do you do about this? Or what is Trail of Bits doing about this? Because I'm here representing that I'm an expert. I'm trying to fix this. I'm not just trying to make people lose money. So we put a flag in the ground and created an authoritative benchmark for discovering security issues in Solidity smart contracts. So we made a database of example vulnerabilities in real contracts that we can use to test the effectiveness of tools that have been created. So if the Securify folks believe in their technology, they could evaluate it against this data set to prove that they can find issues that my tools cannot. And there might be compositions of tools that need to be made where certain tools can find certain kinds of bugs and other tools can find other kinds of bugs, and you need to find the optimal mix. This also creates a benchmark for the language developers themselves, where Solidity should not have the ability to create these bugs in the first place, and this creates a good benchmark for them to eventually remove those features and fix those issues. The second thing we did is, and this is just like a great, one of the reasons that I'm so excited about this field is that it's all greenfield. Like until we started working in the Ethereum space, there was no static analyzer that existed. And we created the very first one. So this is Slither. It's a tool that we use at Trail of Bits, where after every single audit that we do, we collect all the new vulnerability classes we found and implement checks for them in one static analysis system that we then push out to all of our customers, so they immediately get the benefit of new knowledge that we've gained. It allows us to extend our presence farther than if we just reviewed everything with our brains and didn't tell anybody when we made new discoveries. So this is a programmatic way I can share new knowledge. We also created the first fuzzer. Some people in the room might be aware of technologies like AFL or libfuzzer, or let's just call them automated security testing tools that generate purposefully malicious input to see if they can make a piece of code fail. They're a stress test for code. And since we're dealing with finance bots, these are pretty important. Echidna is our best effort at creating a fuzzer for smart contracts. You give it a smart contract, and it figures out what kinds of inputs it needs to take, and then sends it purposefully malicious data to see if it fails. We found many, many bugs with this. It's incredibly effective. It's very dumb. We love it. And then the last thing we did is we also created the very first smart contract verification system. Nearly 2 years ago, we created a symbolic execution framework that operates on top of Solidity that operates on top of Ethereum virtual machine bytecode that allows us to investigate possible states that a contract could get into. So this lets us peer into the future of what could possibly happen to this contract that we might not want. And then based on that information, we can fix the code today. So the formal verification at work here is actually quite dumb when you compare it to probably the efforts of like the K semantics that Cornell Tech is working on, and maybe even the Securify folks. But we can do this via path exhaustion. We can actually exhaust every possible future the contract could ever get itself into and verify it that way with a technique like symbolic execution that lets you get very low startup costs. So you could train a developer how to do this in about 30 minutes. That's why we like Manticore. Low effort, high output. So what I'd like to just recap here is that Ethereum is a really cool technology that enables a lot of interesting possible business opportunities. You know, it's the kind of, it allows you to create applications that live on the blockchain instead of simply transfer value between people. So enterprises are predominantly interested in technologies like this one. But the efforts to build these tools are very young and very immature, and people are suffering because of that. So today, what that means is hacking these things is quite easy, and that they typically do fail in practice. And we're not going to get out of this weird, teenage years for a number of more years. but that it's an opportunity for researchers and for companies like my own and people that are in the audience interested in this technology to contribute their work to this field and have an outsized impact, and an impact that's rapidly adopted by this community, since everyone that's working in this field understands the risk of failure. So if you want to keep up with me, we have public Twitter. We blog a lot of our research on this website, including all of our blockchain work and much else that we do. So thank you.